So I stopped the last video before I gave you the work for these two problems, and so this is the work for each of the problems. Just set up a TXY chart for each one and pick values of t that range from, as you can see here, the t ranges from 0 to 2, and so we start at 0, just keep increasing t by 1 until we get to the end of the interval. And so we go 0, 1, and 2, and we find the values of x and y are here, and we see we plot the 3 points, which shows us direction. So each of these, again, with that added parameter t, we get to know not only the shape of the curve, but we also get to know the direction. Now, here's the deal. If you are sitting there and you did not get these right, then watch the rest of this video. If you got them right, then there's no need to watch the rest of this video, because I'm going to show you some more examples that are just like the ones that you just did, and I'm going to work them out from the beginning. So anyway, when you see parametric equations, you know that you've got a t, x, y chart, t, x, and y. You just pick values of t, and for this particular one, t ranges from 0 to 2. So you just pick values of t, 0, 1, and 2. Okay, now again, x and y both depend on t. If t is 0, we see that x is -3, -3. And then y, if t is 0, is 2 times 0 plus 4, which is 4. Okay, you just keep doing this. Just make your xy chart with an extra t in there and pick values of t and then get the x and y. If t is 1, you get x is -2. T is 1, y is 6. T is 2, x is -1. And let's see, 2 times 2 is 4, plus 4 is 8. So once you get those values, then you make your x and y axes and you plot the points. -3, 4 is right up there somewhere. I'm not getting too particular about this. -2, 6 is right up there somewhere. Hard to draw dots with this thing. -1, 8 is right up there. And since t only ranges from 0 to 2, we have to start where t was 0 and end where t is 2. So we can show direction. And let me indicate this right here. This point right there is when t is equal to 0. And that point right there, that's where the object is when t is equal to 2. And for that matter, the object is right in the middle when t is equal to 1. So again, not only do we get to find out what the x and y coordinates are of any point on the curve, but we also get to show a motion, because we have direction. We start here, and we end here, just like drawing the line. You start in one place and go to another. When you get to calculus, you're going to see things like this. Just to give you a quick heads up, you get to calculus, it's like you put a bug on your paper and then you can see the bug go all over the place, and you get motion in two directions and stuff like that, and you can figure out where the object is at any particular time. Okay, again, I'm going to do a couple more problems. Let's see here. Let's do, I'm looking at page 694, number 12. Page 694, number 12. The one I just did was page 694, number, what was that? Number 8. Okay. And so what is this one? We've got x equals radical t plus 4, and we have y equals radical t minus 4 for t greater than or equal to 0. Okay, so again, just setting up our TXY chart, we just pick values of t. Okay, 0, 1, 2, and you know what? That radical t, I don't like to pick that value of 2. I'm going to pick 4 and 9 because I need to take the square root of t. And I'm going to also increase the size of my red here. Alright, so when t equals 0, x equals 4, and then y equals -4. For 1, we get 1 plus 4 is 5, 1 minus 4 is -3. For 4, when t equals 4, we get radical 4 is 2, 2 plus 4 is 6, 2 minus 4 is -2. And finally, when t is 9, we get radical t is 3, 3 plus 4 is 7, and 3 minus 4 is negative 1. And so we do our thing again. I don't have to get too crazy about this, but again, t is greater than 0, so this is going to keep going on forever. 4, negative 4 is right around there somewhere. 5, negative 3, right around there. You can see, hopefully you can see that this is linear. 6, negative 2, where is that? 6, negative 2, that doesn't look very linear, does it? Maybe I should do a better job at this. Let's do this. Let me put the axis right on a number. Close. It's hard to get that exactly right on there. Let's put this right there. Oh, that was a good one. Okay, and so let's make this really good here. Let's make those bigger. Okay, so 4, negative 4 over 4 and down 4. You can see a dot there. Over 5 and down 3. Over 6 and down 2. And then 7. Oh, I didn't even put that. What is that? 9, negative 1. Oh, I erased it. And then 7, negative 1. So 7, negative 1. So we can see we have a line that has a slope of 1. And let me make that actually a line there. So we start here and we have a slope of 1. And again, guys, this has direction. I don't know if you're tired of me saying that. But when t equals 0, the object is right there. Right there. And then when t equals 1 and so forth, as t ranges from 0 to infinity, this line keeps going on forever in that direction. So that's it for this video. If you need more help than that, then just watch the next few videos, and hopefully you'll get a better idea. Or maybe just replay these last 2 videos. That should give you a good idea. The bottom line is, parametric equations are basically a method for defining a curve in which x and y are, and you should be able to finish the sentence. Let me do that. Let me finish this video by saying that. Parametric equations are, again, you should be able to finish the sentence, a method for defining a curve in which x and y are dependent variables dependent upon a parameter, and normally we use t. So x and y both depend. The coordinates of any point on a curve depend upon a third variable, and we call it a parameter. And again, we usually use t. So x and y depend on t. Pick t, you get your x and y, and that shows motion. So we're good to go.